and machine one of the IGES files that were sent through. I've opened 3D Cam and imported this IGES file. So the first thing to do is to set where I want the machining datum to be. So to do that, I go into milling, set origin, and then choose from the options here. So in this case we'll have the minimum in X and Y and the maximum in Z, and that moves the model so that it's coincident with XY in the bottom left hand corner, and the top of the part is Z0. Okay, so we need to create some sketches to machine this. So I'm not sure how you want to do it, but I'll just assume that you need to rough out the whole thing and then profile around the outside. So if I turn it over and right click and say pick faces, then I can pick up any of these faces. If I right click the mouse and say make a sketch from that face, then that gives me a 2D sketch there, which I can then use as a boundary for a pocketing operation. The size of the part, I don't know if this is the right size or not, but that's what a 20mm tool looks like, so it's either scaled up or scaled down, or it's the exact size you need it to be. So if it is scaled and you need to scale it down, then you go into geometry and you can scale it up or down as you need to. So I'll have to assume that it's the right size. So if I use a 20mm tool for roughing, so on sketch 1, that's what we're going to use, and I need to create a surface because I'll be using a surface to limit the machining. So this will just create a surface from that solid model. Okay, so I've got my sketch, I've got my surface, and I know what tools I'm going to use. So if I right click on the sketch and say new pocketing operation, this is where I set the step over of the tool. So if this was a roughing operation, maybe half the tool size. The material allowance, if I was internal pocketing, then I'd make this a plus value, but if I want the tool to go past the boundary to machine right to the edges, then I can put in a minus figure here. If we start at the boundary and we'll climb mill, we either use zigzag machining or contour style, so it follows the shape of the sketch. The tool we want to use, 20mm end mill, the surface is one we created, and then the clearance plane is a position above Z0, which in this case is the top of the job, so that's where it's safe to rapid in X and Y, clear of any obstructions. The feed change plane is as the tool is plunging towards the job, that's where it will change between rapid and feed rate. Work surface, which is the top of the job, is Z0. The depth is however deep you need it to go. If you need it to take a number of step downs, then you can do. If there's extra stock on the top, then obviously you could set the work surface to be above that. So then here we set the spindle speed and the feed rates to be wherever you need them to be. Okay, so click OK, and that goes away, and as you can see from the objects window here, that's recalculating pocket 1. So the speed of calculation depends very much on the size and complexity of the component and the speed of your PC. I've got this running just on a pretty standard laptop. Okay, so that took just over a minute to produce that toolpath. So that's the roughing toolpath on there, and obviously we could set the Z steps down if we needed to machine from a solid piece. The next thing would be to see how you're going to do some finishing on the sort of top area, the T shape, and the two parts either side of that. So for the time being, I'll just go into pocket 1 and then just deactivate that and make it invisible so that we don't see that on the screen. So what I now need to do is to create another sketch from this top surface here. So right click, make a sketch. So now I've got that as another sketch, so we can do a finishing operation on that. So we could do pocketing operation, set the step over, material allowance this time can be 0, start at the outside, and this time we'll use a ball nose end mill, but if we don't have one we can create one. So if I just cancel that and create another tool, which will be a ball end mill, 20mm diameter. Okay, so I've got a ball end mill I can use on sketch 2. Pocketing operation, material allowance 0. The tool is a ball end mill. Set the depth, set the finishing depth if we need to, but in this case it's not going through the part, so we don't need that. Yep, so I think that's that. So that will now recalculate the top surface. So as you can see, when I'm doing this, I'm just taking a guess at how it's going to be machined and the sort of step overs that you would need for roughing. Obviously you'd need to modify those settings for a finishing operation, but this is just to give you a gist of how we actually go about machining these sorts of shapes. Okay, so that's machined the top surface. Now the second, or the other parts of the shape, these two areas here, we need to use a slightly different routine to machine those. We could, if we wanted to, go around and select the edges for each one of those shapes and create a sketch from it. But actually what's kind of easier is if I take the two sketches that we've already got and I make copies of them. So sketch 1, if I right click and say copy, and then with the cursor in the objects area I right click and say paste. So I've now got two copies of that sketch I created, and to rename them so that I'm sure of what they are, then if I come down into the properties window here, then I can rename that copy of outer, and then the same thing I'll do copy, paste. So now I've got another copy of the T shape. So if I rename that copy of T, then what I can do with the outer and the T, if I hold down the control key when I select them, right click and say combine sketches. So now I've got a sketch which is got an outside and it's got an island. So I can now use that as a pocketing command. So if I use pocketing, we'll set the step over to 10. Yeah, we'll probably use that style. We'll use, say, quite a big tool there, and yeah, just leave all that as it is, I guess. We can always come back and modify these things. The thing to do when you're using the system is not to make the step over as small as it's practically possible that you need it, because it just takes longer to calculate. So make all your tool paths as you need them to be, and then you can go back and modify them, and then just run all the tool paths and recalculate with a very fine step over, and maybe have a cup of coffee whilst you're waiting. Okay, so what that is doing is it's using the outer shape and as the outside boundary, and it's using the T as an island, and it's producing the toolpath which will just machine the areas between the two. So if we just want to hide that one there, so pocket number 4 is the one where we use the combined the sketches to produce an island and an outside boundary. Okay, so maybe the last thing to do would just be to profile around the outside of that. So that's the sketch for the outside. Right click, profile operation, we'll climb mill. If you want to use a roll radius, that will determine the amount of roll on and roll off on the job. If you want to use a roughing and semi-finishing, then we can do here. Use this tool. I don't need for it to be based on a surface, because it's a simple 2D profiling operation. Okay, so that's machined that. So then we can just run that through the simulator and the job's done.